All right, so it is Tuesday, September 17th, and it is 7 o'clock. And so we're going to go ahead and start in with Zoom session number 5. And our focus for Zoom session number 5 is going to be BGP. And Zoom session number 6 is going to be BGP. And probably a little bit of Zoom session number 7, our final Zoom session, we'll be talking a little bit about BGP as well. And so BGP is really one of the major topics in the course, as evidenced by the length of the chapter and the fact that it's been broken down into 2 weeks. And so just to give you some background, right? So to this point in the course, we've talked about interior gateway routing protocols, or IGPs. And those are protocols that you typically run within your enterprise, between the routers that you have administrative control over and authority over. So BGP, or the Border Gateway Protocol, is a protocol that is used to provide inter, and not intra, but inter autonomous system communications. Now, BGP has a lot of applications. We're going to cover the basic applications of BGP. And so the way I want you to think about it is BGP is a routing protocol that would allow company A to talk to company B, right? And they could exchange routing information. Or you could think of it as company A is connected to a service provider. And when we're talking about a company, we're talking about a larger company, right? A company that would have multiple routers that might have connections to the internet and to different service providers, providing them that transit connectivity to connect to the internet. And that is where BGP comes into play. I think the chapter does a very, very good job in explaining that BGP is not for everyone. And I've kind of talked about this a little bit as well. So if I was to just draw something up here real quick, and this is kind of an easy one. So let's say we've got company A, right? And they have a single connection out here to their service provider. And let's say that it's Verizon, right? I'll say Verizon, right? So if company A has a single connection to Verizon, it's not really necessary for company A to run BGP, because BGP, and this is an analogy that I've heard used often, BGP is less of a routing protocol and more of a policy application tool, right? Now, it's definitely a routing protocol, but when you start to get into what you can do with BGP, it's more about sort of policy and policy routing, where you're creating a bunch of policies to say, if I have multiple links, I want to prefer this link, right? And maybe I want to prefer this specific link only for this route or this network. And that's where BGP really shines. In a scenario like this here on the left, right, there's not really a need to run BGP here. And typically what you would see is company A would simply have a static route, right? A default static route that says, yeah, all traffic that I don't have a longer, more specific match for internally in my network that's back here, send it out to Verizon, right? And then it would be right here on that interface where company A could be doing dynamic NAT, right? Or NAT overload, which is referred to as PAT, port address translation. If they had a block of public IPs on that were assigned to them, they could do static NAT, and a combination of static and dynamic, or static and port address translation, which is referred to as NAT overload. So that's the scenario here, right? Is that typically you would see just a default route. It doesn't make sense to configure BGP in that scenario right there. Now, again, and I can't stress this enough, it's all about the use case, right? So what is your use case? What are you trying to achieve? And that is what should drive the protocol that you use. And so in the education field, they refer to that as missional, right? Missional thinking, where we know what we want to do, and then we pick the tool that we want to use from a routing protocol perspective, right? So if all I want to do is do port address translation with my provider, I don't have any web servers, so I don't have anything that someone's going to initiate connections to me on. I just need outbound connectivity. Well, then I would do NAT overload, right? Port address translation with a single address, and probably tie it to the interface, because the provider is going to be giving me that space if it's provider aggregatable, which chances are it is if I'm a smaller company and I don't have my own provider independent space, right? So that's the typical scenario where BGP is not really needed. Where it's needed is when router A has another BGP connection to Verizon, and then over here, router A has a BGP connection to Comcast, and maybe over here, they've got a BGP connection to Hurricane Electric, which is a very weird name, but again, they're a quite large service provider. I think they're a tier 2 service provider. So now router A has 4 4 connections here to different service providers. This is a use case for BGP. So when we look at the drawing that we have right here, right, we can see that that's going to be autonomous system 1. This nice little bow tie in here is going to be autonomous system 2, 3, 4, 5, 7, right? So it's all together 2, 3, 4, 5, 7. And then down here, it's just going to be autonomous system 6. So we've got 3 different autonomous systems. Now, this autonomous system here, 2, 3, 4, 5, 7, would be referred to as a transit autonomous system, because it's providing transit connectivity from autonomous system 6 up to 1, and from 1 down to 6. And maybe there's other autonomous systems or providers that are hanging off here of this autonomous system. So this is a transit autonomous system. Now, the way that we would configure BGP here is we're going to set up eBGP between router 1 and 2 and 1 and 3. And the same will be true of 6 and 5 and 6 and 4. Now, I've already set up all the IP addressing, and we'll take a look at it, and we'll talk about the IP addressing. Now, BGP is different than your IGPs from the sense that when you make a connection, right? Remember with EIGRP and OSPF, we would configure the process on an interface. And then that interface would start multicasting out, right? OSPF to 224.0.0.5. And that's the all OSPF routers multicast address. EIGRP 224.0.0.10, which is anyone who's running the EIGRP process on an interface is going to be listening for that multicast traffic. So with BGP, it's deliberate, right? Now, there are ways that you can set BGP up so that it auto-magically allows a BGP connection to be formed. However, we're going to talk about it in the sense of it's very deliberate, which means, because again, it's between autonomous systems, right? And another analogy, when we talk about the best path, like which path is the best, when we looked at the IGPs, right? When we looked at OSPF and EIGRP, with OSPF, you had the metric, right? And with EIGRP, you had a metric referred to as the composite metric, and lower was always better. Now, with BGP, that's not necessarily the case, right? It's not looking at some sort of bandwidth value like EIGRP and OSPF. It's looking at the autonomous system path length, right? So it's looking for the shortest number of autonomous systems to get from where it's at to where it's going. And that is what BGP uses. So it will receive different paths, and it basically tries to determine what is my shortest path to get from my autonomous system to my destination. And again, the number one criteria by default is going to be the autonomous system path length. And that's what BGP is going to look at. Now, remember, I said that BGP is more of a policy, it's more of an application, policy application, because that's where with BGP, we can manipulate very easily the path that gets taken on a per prefix basis. Now remember, with the interior gateway routing protocols, if we did any traffic engineering, right, when I tweak the delay on an interface going in the outbound direction to try to manipulate and do layer 3 traffic engineering with EIGRP, or with OSPF, if I was to set the IP OSPF cost on an interface, that affected all the traffic, right? And that's different than what we can do with BGP. BGP gives us much more granular control. And so again, I want you, when you look at this diagram, I want you to think of, you got, company A, company B, and company C, right? Because these are 3 different autonomous systems. And we'll just look at it in terms of, this is a service provider, here's a company here, and here's a company here, and they're passing the routing information through. And so the focus and the goal tonight is going to be to get the peering set up. And when we get here, you can see we've got a lot of IBGP peerings that are going to have to be set up. And I'm going to do it the non-optimal way, because we have to see what it would look like in a non-optimal configuration, because next week we're going to get into sort of policy and manipulating things, and we're going to talk about route reflectors. And router 7 is ultimately next week going to become our route reflector. And so I'm going to show you how to set up route reflection as well. So let's clear the screen here and let's get on the command line. And again, if you have any questions, feel free to type them into the Zoom chat window that's over here on the bottom right. At least on my screen, it's on the bottom right. And again, we talked about the autonomous system path length. So let's take a look at router 1. And again, the configuration of BGP is very, very straightforward. It is not difficult to set up an eBGP peering. In fact, I'm going to show you right now just how simple and easy it is to set up an external, right? And let me take a step back. So when we talk about BGP, the Border Gateway Protocol, there's going to be 2 ways that we configure it. One is going to be between autonomous systems. That would be considered an exterior Border Gateway Protocol, or eBGP. E is an Edward for exterior, an eBGP peering. And it's very simple. The way that you determine, is this an eBGP peering, are the autonomous system numbers different? If the autonomous system numbers between the routers are different, it's eBGP, right? And on the opposite, if the autonomous system numbers are the same, it's IBGP, or interior gateway routing, interior border gateway router protocol, IBGP. All right, so I'm on router 1 here, and let's take a look at how easy it is to get BGP set up. So I would go into global config. Now I'm going to say router BGP 1. And if I back up here, you can see that's my autonomous system number. Now, there are some cases where you can use this decimal, right? The dot notation in the autonomous system number, because originally there were not a ton of autonomous system numbers. And so the idea was, well, we've got to come up with a way to extend the number of available autonomous system numbers. And you can see now that there are 4.2 billion, so it's a 32-bit value. And you can do this dot notation, which extends out the amount of autonomous systems that can be configured. But again, we're going to stick just with router BGP 1, right? So now I'm in the BGP configuration. So the first thing that you want to do, one of the most important things you want to do, is you want to hard code the BGP router ID. Now, typically, this would be a loopback address of some kind that you have configured. So for us, we would say BGP router ID, and I'll just hard code it to 1.1.1.1. And if I say do show IP interface brief, you can see that we have loopback 0, and you can see that we've got the IP addresses configured here. And again, the third octet is the key because it just basically shows you the 12 means it's between router 1 and router 2, and 13 means between router 1 and 3. Now, when you're looking at this, you may be saying, wait a second, that address looks very, very familiar. That 169.254, I've seen that before somewhere. And there's a very good chance that you may have seen that address before somewhere. So this is referred to as an APIPA, right? And this is what happens when you don't get a DHCP address. You know, maybe your laptop or desktop is disconnected and it doesn't get a DHCP address, right? And so then it defaults back to these, what they refer to as APIPA addresses. Now, I'm going to say something here that when I did this last time I taught the route course, a learner immediately typed in the window and said, hey, you misspoke. There are no link local addresses in IPv4. Well, I'm here to tell you, and because they thought it was an IPv6 thing, right? Where, you know, you hear about the link local like the FE80::1 or FE80::2. And in IPv6, those are referred to as link local addresses. And there's this misconception that link local addresses don't exist in IPv4. Well, they do. And there's something very special about the link local address. And, you know, just like link local addresses in IPv6, right? You can't route traffic to a link local address, right? Like I can't advertise a link local address because by definition, it is local to that segment, to that link between the routers, right? And the same is true of these addresses, the 169.254.0.0/16. So I could go 169.254.0.0 all the way up to 169.254.255.255, right? So it's a huge range. So there's a great use case for this range of addresses. And this is one of those use cases. Because if you're peering with an internet service provider, right, if you have control over that, and this is, we're not talking about when you would be using NAT, especially if you're using port address translation, because those addresses, the 169.254, those are not routable on the public internet. But here is why they are ideal in a case where you're peering with a service provider and you don't need to use the interface IP to do any kind of NATing. And it's because those addresses aren't reachable over the internet. So if someone was trying to hack your router over the internet and they're trying to get to it on the 169.254, right, they're never going to get there because you can't, that 169.254 is not routed over the internet. Now, the opposite side of that, think of it like this. So what if you did say, you know, you take the address that the provider gives you and it's, you know, 209.165, whatever, right? That is publicly routable. And if that's the IP on your interface between the peering, right, it might be reachable from other locations on the internet, right, that are going right after that router, trying to get to that address, okay? So that's why you would use an IPv4 link local address between the routers for the BGP peering. Now, again, it's not ideal in every use case, but for the use case that we're doing here, it's a great idea, right? Because it's going to protect the router. It's just another layer of protection because now my router is not directly reachable over the internet, right? Now, once we start advertising what's referred to as NLRI or network layer reachability information, then we are reachable, right? But from this perspective, we're not. And this is a great way to protect your router. So we're in the configuration here, and you can see that I'm going to have a peering with router 2 and with router 3. So what do we have so far? So do show run section router BGP. And we can see here that we've got our BGP router ID set. Now the log neighbor changes, that's on by default, so that they kind of throw that in with the package. And so that's there. So now the next thing is we're going to set the neighbor statement. And here's how you configure an eBGP peering. So I'm going to say neighbor, and I would put the IP address in 169.254, and we'll do router 2 first, .12.1, and I put the remote AS. Remember, this is what is determining if it's an external or exterior BGP connection, or is it an internal iBGP connection. And again, it's going to be 23457 is the autonomous system. Remember, that's not it's not router 1's AS. My AS is 1. That's an eBGP connection. I apologize. I put down the wrong IP there. So you can't create a peering to yourself. All right, so this is going to be easy to do the next one, right? I'm just going to come over here and say 3.3, and that is router 3. So what does our configuration look like right now? So do show run section router BGP, and that's what we have right there. And again, very easy to configure. This is all I need right now. So router 1, for our purposes right now and what we're doing, router 1 is fully configured for 2 eBGP peerings, one with router 2, one with router 3. So let's step over to router 2 and 3, and let's do the same thing. So I'll go into global config. I'm going to say router BGP 23457. And again, I'm going to put the 2 neighbor statements in. So 169.254.12.1, because that's router 1, and I say remote AS is 1. Now I'm going to hit enter, and this is one of the things that you'll see as we work through the different demonstrations, is with the interior gateway routing protocols, things happen super fast, right? You know, you would type in the network statement with OSPF and boom, adjacency comes up. Or you would type your network statement with EIGRP and boom, adjacency comes up. BGP takes its time. It's very slow because, and this is a significant difference, BGP, remember I said it's deliberate. It's going to form a TCP session, right? So the BGP routing protocol leverages the TCP suite of features, right? And it uses that instead of having, like EIGRP has the reliable transport protocol, right? So BGP, when they did BGP, they said, yeah, we're not going to come up with like all this stuff like EIGRP did and come up with like its own type of keep alive system and things like that. No. We're going to use we're going to leverage TCP to do that. So a TCP session on port 179 is going to be set up between these 2 routers. I hit enter, and it's going to take, typically it takes a couple seconds, and there we go. So it's pretty quick. So you can see adjacency up. So how could I confirm that? I could say do show IP BGP summary. And you can see we've got the neighbor address, right? So that's router 1's IP. Now the V is the version of BGP. Now it's version 4, but don't confuse that with it only does IPv4. We can do IPv6. It just so happens that the version number would, and it's been BGP version 4 for a really, really long time. BGP has been around for a long time. And that's just the version number. You can see that router 1's autonomous system number shows up here. We're exchanging messages, right? We haven't, the update messages and the hello and the keep alive messages. The table version, we haven't made any changes, right? No network layer reachability information. That's just a fancy way to refer to prefixes, right? Or the routes that we would be receiving or sharing. Nothing has changed. So my table version is just version 1. The input queue and the output queue, you want to see zeros here because you don't want to see that things are queued up. Because if things are queued up, that means that either you've got some latency, some slowness of some kind, something is preventing the input queue and output queue from flushing and staying up to date. Now, this is how long the adjacency has been up, right? So it says up, down. So at this point, it had been 9 seconds if I was to rerun the command. you can, oops, sorry, you can see that we're at 1 minute and 30 seconds. And then this is really important over here. The state or the prefixes received. So the state, it could show you that the adjacency is down, right? It would say down. If it says anything, if it shows you anything other than an integer in that field, and by integer I mean 0 or greater, right? So any integer greater than or equal to 0, if there is not an integer greater than or equal to 0 here, your peering is not established, right? You do not have a BGP peering established. When you see prefixes received 0 or greater, you know, so like 1, 55, whatever, this just means how many prefixes I've received from that neighbor, right? And so we're going to circle back and put the network command in. We're going to start advertising some stuff here shortly. So let's go over to router 3 and let's bring up the peering between router 1 and router 3. So I'll go into global config and we'll say router BGP 2, 3, 4, 5, 7. Now remember, routers 2, 3, 4, 5, and 7, they're all in autonomous system 2, 3, 4, 5, 7, right? So they're going to have the same AS number. And you know what I didn't do over here? BGP router ID, and we'll set that to 22222 for router 2. And so again, first thing we'll do on router 3 is we'll say BGP router ID is 33333. And then I'm going to say neighbor 169.254.13.1. And then router 1's autonomous system is autonomous system 1. And we should see here within the next couple of seconds. And there we go, pretty quick. So how do I confirm? Do show IP BGP summary. Okay, perfect. So router 1 has been configured and it's got eBGP peerings with both router 2 and router 3. If I was to say do show IP BGP neighbor, right? This is another great command that gives you a ton of information. So you can see here, BGP router identifier. So there's my router ID. Here's my local autonomous system number. And most important in this output here that you see, I'm sorry, I went too far up. So we see the BGP peering here. There's the neighbor, the remote AS. But what we're looking for is that right there, external link. And that confirms that this is an eBGP peering. It's between autonomous systems. And the BGP state is established. It shows me the uptime. And then there's a bunch of additional information that you're going to see in here that it will show you. And we'll come down to the very bottom here. I'm just looking if there's anything else we want to grab right now. So the next thing I'm going to do is, remember I said it's TCP is how it's connected. So if I say, and this is a great command to run to check to see what kind of TCP sessions or which TCP sessions are established. So if I say do show TCP brief, right? If you say do show TCP brief, this will show you the TCP connections that exist. And there is your port 179. And so what this shows me is that between these two routers, the server, right, is going to be router 3 because it listened on 179 and the connection has been made on 179 on router 3. And then the session was initiated from router 1, right? And so we can see that here. Maybe some more interesting output here. Do show TCP brief, right? And you can see router 1 has 2 BGP sessions, one with router 1, I'm sorry, with router 3 and with router 2. And again, you can see that the higher router ID is the server, and the lower router ID is coming out on that random high port right there, establishing the connection. So we've got the eBGP peerings here. So now let's go ahead and let me advertise the loopback address, which is the 1111. And I'm going to show you a very popular mistake that many learners make. And not just learners, but you'll see this mistake made quite often among network engineers that are new to BGP. So we're in the BGP section. And here's what we've got right now. And so now I want to advertise a network. So we do that with the network command. Now, and actually, let me show you real quick. Do show IP interface brief. You can see we have loopback 0 is 1111, right? So if I was to say network 1.0.0.0, right, because it's a class A address, and then say mask 255.0.0.0, sorry, .0.0.0. Now, this is the mistake that gets made, is that whatever that loopback address is configured for in terms of the subnet mask length has to be an exact match unless it falls on the natural boundary. And so let me show you what I mean. So here's the network statement, 1.0.0, and you would look at that and say, oh yeah, well, 1111 falls within that range, right? So I'll hit enter, and we'll come over here to router 2, and this is how we would see the routes we've received. I say do show IP BGP. Well, you'll notice I'm not receiving anything, right? So let's come back over to router 1. Well, there's a way I can check on the router to see, well, what am I advertising to my neighbor? So I would say do show IP BGP neighbor 169.254.12.2 for router 2. And then I would say advertised routes, advertised dash routes, right? And that command is going to show me what am I advertising to router 2. I'm not advertising anything. And the reason that I'm not advertising anything, do show run interface loopback 0, excuse me, is you can see that this is a /32 subnet mask length. So again, do show run section router BGP. So the problem here is that the network statement I put in, and you can see it even dropped the 255.0.0.0 for the subnet mask length, because the natural mask, that is the natural mask, right, is 255.0.0.0/8. So when I put this in, it does not match exactly what we have on that loopback address, the loopback interface. So let's fix that. So I'm going to say no network 1.0.0.0, and then let's confirm that that's gone. Do show run section router BGP, so it's gone. So now let's say network 1111 mask all 255s. Again, it has to match exactly, or else it's not going to advertise it. The only, and what's the word I'm looking for? I just lost the word. Not alternative, exception. The only exception to this is when what you're advertising, which is what I'm going to show you next, falls on that natural boundary, right? So I say network 1111, I put the mask in 255, 255, 255, 255 for the /32. Now when I come back with the do show advertised routes, aha! So now I am advertising the 1111, and you can see the next hop, when it's quad zeros, that means that I originated this route. And again, I'm router 1, I advertise it, so the next hop is quad zeros. That means the next hop is me, I originated. The metric is 0, right? And that's what referred to as the med. We'll be talking about that next week. You can see the weight, and we'll talk. So we're going to talk about all of these attributes next week, as we're going to get in and start manipulating things. So the weight is 32,768 by default, and the path, excuse me, comes up as I, right? How did we originate it? It was originated with the network command, or the origin, right? It's IGP. And when I use the network command, it's going to advertise it, and you'll see that on the other routers that learn it, they see it as being learned. It's an IGP route that was advertised because I use a network command. If I were to have redistributed the information into BGP, you would see a question mark here. And it's unfortunate. This is one of the things that drives me crazy about Cisco and the way that they display the path. Because you see how the I falls under that path heading? Well, the I isn't the path. The I is the origin code. How was that NLRI? Was that network layer reachability information, those routes, how was it learned, right? I'm sorry, how was it advertised? And so the I, when we look at the other routers, router 2 and 3, you'll see that the path is going to show up here, and then the I gets pushed over to the right. But there's never a header column for the I. It never says origin anywhere. You just see that, you either see the I or you see the question mark. Now, the E in real life, you should never, ever, ever, ever see the E, because the E means that it was originated from EGP, and EGP was the predecessor to BGP. And the book did a great job talking about how EGP has not been used in like ages. However, if you've got really old versions of code, you can set the origin, and there's really not a good use case or argument to do it. You could set the origin code to EGP if you wanted to, right? If you had some really old code. In fact, the newer code, it doesn't even allow you to set the origin to EGP, because no one's using EGP. And the reason that it's there, or that it was there, was it was used as part of a transition mechanism when they were the internet was transitioning from EGP, which simply just did not scale, to BGP. That's what it was used for back in the old days. But today, there is no legitimate reason or use case that I can think of that you would be using or setting the origin code to EGP. There are so many other ways that you can manipulate and do layer 3 traffic engineering with BGP, that manipulating the origin code and setting it to EGP is not one. Okay, so again, remember over here, that path column is going to start to look really funky when we look at other routers. So we come over to router 2, and let's say do show IP BGP. And here you go. Take a look at what's going on in the path now. So now we've learned from Autonomous System 1, and this is the path and that path length that I was talking about. This is what that's all about, is router 2, if it has more than one path to get there, right, more than one BGP path to get there, is simply going to say, what's the fewest number of autonomous systems I need to go through? Now, this may not be optimal, okay? Because remember, BGP doesn't care about the speed of the link. So if I was to come over to our photo here, right, and let's say that, let me change the color here to yellow. So let's say that router 1 is trying to, because, and you know, we're going to advertise the loop back on router 6 here in a couple minutes. So router 1 is going to learn about the 6666 from router 2, and it's also going to learn about it from router 3. And BGP has a very complex decision process that it goes through. And it's like the 12-step process, basically. It's more than 12 steps, but you'll hear people refer to sometimes like the 12-step program. And so router 1 is going to learn about the 6666 from router 2 and router 3. And so the first thing it's going to try to evaluate by default, right, this is before we've manipulated things, is it's going to look at the autonomous system path length, right? And so that is where it's going to look to say, is there a shorter way to go? So let's say, just for the sake of argument, that the shortest and best path, right, the shortest autonomous system path is through router 2. But what if this is a T1 and this is 100 gigabit per second link, right? Whoops, gigabit per second link. So it learns it from router 2, and that happens to be the shortest AS path. Router 1 is going to say, oh, this is awesome. I'm going to use the T1, which is 1.544 megabits, which is very slow compared to 100 gigabits per second. Now, obviously, you're not going to let this happen, and that's where the layer 3 traffic engineering would come into play. However, it's to prove a point, right? That BGP, with respect to choosing the shortest AS path, is very similar to which routing protocol? Let me ask you, which interior gateway routing protocol is BGP very similar to in determining the best path? And again, BGP simply says, yeah, shortest AS path, that's the way I'm going to go. By default, right? Again, I keep stressing by default because we can get in there, and you do. When you're running BGP, you're going to be doing all these policy applications to ensure you're going out and you've got well-determined paths you're taking. So it's RIP, right? Remember RIP? RIP was all about the fewest hops, right? RIP had hop count as its metric. And RIP doesn't care. RIP never looks at the interface to say, well, what's the speed of the interface, right? That's what OSPF and EIGRP take into account when they're calculating their metric. But RIP didn't care. RIP just said, hey, what's the fewest amount of hops? BGP is very similar in that aspect. Now, remember, BGP is not a distance vector routing protocol. It is a path vector. And again, if you think about it, right, they say that, RIP is distance vector, right? And it looks at the hop count. Well, BGP is path vector. It looks at the autonomous system path length by default. So that's why it's classified as a path vector routing protocol. So let's go back to our setup here. So now we've got our eBGP peerings configured, and on router 2, we're learning this information here, right? And everything is great. So now let's round out the iBGP configuration between 2, 3, 4, 5, and 7, right? So how would that work? Well, this would become a little more complicated. Now, remember, we're doing iBGP here, which means we need to have reachability, and typically the way that iBGP is done, and remember, it's internal, meaning it's in my organization, my autonomous system under my control. So you would run an IGP like an OSPF or an EIGRP. And the way that you typically set the peerings up with iBGP is to a loopback address. And that's exactly how we're going to do it. Now, remember, we've got a little bit of work to do here from the IGP perspective, but I'm going to keep it very short and sweet. So it's going to be router OSPF1, and, excuse me, I'm simply going to put the networks in here, and actually let me display do show IP interface brief. And so we would walk through this. And so again, I'm not going to run the OSPF process for the eBGP facing interface for this 169, right? Because I'm not going to run OSPF with router 1. We're doing BGP. So I'm going to come in here and I'm going to say network 10.2.3.2 000, and we're going to say area 0. Everything is just going to be area 0 for us here. And I'm going to say network 2222 because I'm going to advertise my loopback address. Whoops, because that's the address I'm going to set my peerings up on. And then I need network 10.2.7.2 quad 0 area 0. Let's do that on router 3. We'll get iBGP set up over here, or I'm sorry, OSPF set up over here so we can do the iBGP. So we'll say router OSPF1. So we say do show IP interface brief. And again, we're going to have network 3333 for our loopback address, area 0. And then network 10.3.5.3, and we'll do the quad zeros, area 0. Network 10.3.7.3, quad zeros, area 0. And that's it for router 3. We'll go to router 4, and we'll do the same thing. Whoops, conf T, router OSPF1. We'll say network 333, I'm sorry, I'm on router 4 here, 4444, area 0. And then network, and actually I need to see the interfaces here. Do show IP interface brief so that I can see what I'm hooked up to here. Okay, network 10.2.4.4. Now I should see some peering start to pop up here because now we've got routers that are connected to each other. 10.4.7.4 quad 0, area 0. And we did do show IP OSPF interfaces. I think I got them all there. Yep. All right. So you can see those are in the waiting state. So it's going to work its way through, and then it's going to set up the OSPF connection. So now we'll move over to router 5. And remember, we're setting the IGP up, OSPF, so that we can have connectivity between all of the routers in my autonomous system, 23457. All right, so router OSPF 1, IP interface brief. Let's make sure we get all the interfaces right here. All right, so we're going to say network 5555 and then 000 area 0, and then network 10.3.5.5 quad 0 area 0, and then network 10.5.7.5, and there we go. We've got a OSPF pairing that just popped up. And then we've got that interface configured for OSPF, and now we'll go to router number 7. And 7 is going to be interesting. It's got quite a bit of connectivity. So show IP interface brief, because it's in the center of our setup. So we've got a few network statements here. Router OSPF 1. So we'll get the loopback address first. And then we're going to get the 10.2.7.7. And we should see these pairings come up here as I'm typing them in for everything here. So there's router 2 is up. So network 10.4.7.7. And this is why the interior gateway routing protocols are taught before BGP, because you need, for IBGP, you need that reachability inside your autonomous system. So I'll say network 10. Where did I leave off? 3.7.7. And then quad 0, area 0. And finally, network 10.5.7.7 and quad 0, area 0. And so we should see that adjacency. So there we go. So everything looks great. So if I say do show IP route OSPF, sorry about that, thinking about what I'm doing, my next steps. So we pick up these transit networks, right? So that's okay, not a big deal. And we could get rid of those if we wanted to. But the important thing is all the loopback addresses. So router 7 sees the loopbacks for 2, 3, 4, and 5. Now we just need to confirm that do show IP route OSPF, that this guy sees 3, 4, 5, 7, right? So we're good there. And then on router 3, do show IP route OSPF. And I'm just making sure that each of the routers in this autonomous system sees the loopback address of all the other routers in the autonomous system, because it's the loopback address to which we're going to create the peering. So we're good there on 3. Let's check 4, do show IP route OSPF. So 2357, and finally, router 5, do show IP route OSPF. And there we go, 2, 3, 4, and 7. So we're good to go. So I've got reachability. So let's come all the way back to router 2. And let's do one check here. We're going to take a look at our drawing, right? So remember, we are now here in this autonomous system number 23457. Now, OSPF is running in here as our interior gateway routing protocol. So we're not going to have OSPF here. Right? There's not going to be any OSPF on that interface. There's not going to be any OSPF on that interface. We don't need it, because that's going to be the interface running BGP. Same thing. We've got OSPF as our interior gateway routing protocol. There will be no OSPF there, because that's an eBGP peering, and no OSPF here. And again, think about it. Do you want to advertise your internal networking information to another autonomous system? Now, there may be use cases where you're doing that, right, that are specific. But in this use case here, the answer is no, is that I don't want the company A in autonomous system 1, I don't want them to see my internal routing information. And router 6, autonomous system 6, it's the same thing. I don't want them seeing my internal routes, because if they can see my internal routes, there's a chance they may try to get to those, right? So we don't want that. So here we go. We're running OSPF on all of our other interfaces in here. So now we're going to set the IBGP peerings up here. And so you may be asking, well, how do I do, how do I do an IBGP peering? And it's actually pretty straightforward, right? It's just as simple, it's almost as simple, I should say, as what we did with the eBGP peering. So the first thing we have is we have that neighbor statement, just like eBGP, same thing. However, here, I'm not using the interface address. I'm using the loopback address of the router I'm going to create the iBGP peering with. So router 2, I need, and again, and let me take a step back here. So you may be asking yourself, well, why are you going to create an adjacency from router 2 to 3, 4, 5, and 7? Why not just create it to one of them? Well, and this is why we're doing it, like I like to refer to this as quote unquote, the hard way, is that with iBGP, there's a requirement that you have a full mesh, because iBGP's loop prevention mechanism, right, is not the autonomous system paths. With eBGP, that's how you prevent loops. If I see my autonomous system show up in an update from another autonomous system with routing information and my autonomous system is in there, a loop, that's a loop. Because that means that I advertise something out with my autonomous system connected, associated with it, and somehow it looped all the way around and came back to me. So with eBGP, the loop prevention mechanism is the autonomous system path. But that doesn't make any sense for iBGP, right? Because we're all the same autonomous system. How would that work, right? It doesn't use the autonomous system path is what I'm trying to say. So the way that it prevents loops is with a full mesh of iBGP peerings. So I'm going to show you how painful this is going to be. So I'm going to say neighbor 3333, right, the loopback address. And again, I would say remote AS, remote, what did I do here? Oh, where did I go? Oh, you know what? So I see config router, right? And I'm thinking, oh, I must be in the BGP router configuration section. But where am I? I'm in the OSPF configuration section. I'm going to need to remember that I need to go into router BGP 23457, and then I'm going to say neighbor 3333. And again, it's the same. Sorry, I didn't want to do that. We're going to put remote AS, and then you put the remote autonomous system number. Well, remember that these are iBGP peerings. So everybody is 2, 3, 4, 5, 7, at least on the iBGP peerings I'm going to create. Now, this is where it gets a little bit more complicated, but not much with iBGP. So since I'm peering to a loopback address, I need to come back and say for the neighbor statement, I need to say that the update source, right? And this is the interface that I'm going to be using to send and receive my BGP updates, is the loopback 0 address, okay? So I would put the remote autonomous system number. I'm going to put the update source. And if you take a look at the other options that you can configure, right, there's quite a few things you can configure here. We can say advertise, right? And where are we at here? I could even say next hop self. Now, this becomes critical, super, super important, right? And I'll show you why. So we say next hop self. So if we take a look at this, do show run section router BGP, we see right now that just for one peering, I'm going to need 3 lines. Right? For one peering, it's going to require 3 lines. So again, I would come here and I would say neighbor 4444, remote AS 23457. I'm going to come back and I'm going to say the update source is the loopback 0 interface. And I'm going to say next hop self. And then I'm going to do the exact same thing for router 5555. And we're going to say remote AS is 23457. The update source is loopback 0 and next hop self. And I'm going to talk about next hop self. Don't let me off the hook. If I forget, ping me in the chat window there. And we're going to say, next hop self. Next hop self. And then finally, neighbor 7777. and the remote AS is mine, 23457. So these are IBGP peerings. And then neighbor 777, the update source would be loopback 0. And finally, next hop self, right? So let's take a look at what we just had to do there. So do show run section router BGP. And I want you to imagine having to do this. Oops, sorry, not grab one too many lines there. I want you to imagine having to do that for every single router. And in fact, we are going to do that, but I'm going to make it a little bit easier here. I'm going to say edit copy. I'm going to pull up brackets and we're going to say file new. And so this code that's here, right? And let me bring it down on the screen a little bit. So the code that's here, right? For router 2, this worked great. For router 3, all I would do is change it to 2222. Right? And then we're ready to go. So I just grab it, Control C, or come over here to router 3. And this is going to save us some time. So I want to say router BGP 23457. And then we paste that, sorry, and then we're going to paste that information in. Sorry about that. And it grabbed the last thing I had highlighted, unfortunately. So we'll come back and we'll say Control V. And so it drops all those statements in, right? And you can see the adjacency with router 2 came up, right? And we're going to see that as we work our way through. So we'll go to router 4. Whoops, let me bring this down just a little bit. So now we go to router 4. And we're going to come back in here. And you can see with router 4, I would just simply take out the 4444, and we would need the one that we're missing, which is 3333. So instead of having to type all this out again, we can save ourselves some time by just typing this loopback address 3 times. We do a copy. We come out here to router 4, and I say router BGP 23457, and paste. Right? We go to router 5. So 2, 3, and so we'll just change 5 to 4. And you can see that this is not very exciting. And think of it, I've only got 5 routers that are IBGP peers here. Imagine that you had 10, right? And the reason I'm showing you this, and while you're probably thinking, boy, that is really inefficient, you're absolutely right, it is. And again, it's leading up to next week's conversation. And we should see BGP peerings pop up here on 5 with 3, and we should see 4, and there we go, and 2, right? So we've got 5, so let's wrap it up here with 7, and so 7, we just need 5. There we go. All right, so we've got all of these IBGP statements ready to go here. We're on router 7, and we'll get into global config, and we'll say router BGP 23457. And let's paste everything in. And we should see 4 BGP peerings come up here on router 7. We should see the adjacency with 2, with 3, with 4, and with 5. And there they are. So now we've got some interesting output that we can take a look at here. If I was to say show IP BGP summary, take a look at that, right? We've got quite a bit of information. Now, I want you to focus here on this prefixes received, right? So I'm receiving a prefix from router 2 and router 3, and that prefix was the prefix that was learned from router 1. And so let's see what we've got here. Show IP BGP. And so you can see I've learned it, and I've learned it from 2 different paths, or I should say from 2 different neighbors, right? So the next hop of 3333, so I've learned it from router 3, and I've learned it from router 2. Now you'll notice that I don't have the greater than sign over here. I've got the asterisk, and the asterisk refers to the fact that it's valid, right? Meaning the update was valid, excuse me, and that this is a valid path, but it hasn't determined which path is best yet. But remember, I told you BGP is notoriously slow, super, super slow. So I say show IP BGP, and I gave it some time, and now we have the greater than. So don't panic if you don't see something right away, I usually give it about 30 seconds tops before I start to panic or before I start to look into what the problem might be. So my best path is going to be through router 2. And we'll come back and talk about the best path selection algorithm to kick off the next session. So for right now, just remember, hey, okay, I've learned it, and I've learned it from router 2 and 3, but the best path that I'm going to take, I'm going to go through router 2. Now, you might be asking yourselves, remember when I looked here on router 7 and I said show IP BGP, summary is what I wanted. When I said show IP BGP summary, you may notice that router 4 and 5, I'm not learning anything from them. And it makes sense, right? Because router 6, we haven't configured to advertise anything yet. So 7's not learning anything from 4 and 5. It's learning something from 2 and 3, though. So, but let's take a look at 4. Is 4 learning do show IP BGP? Did it learn the 1111? It did. And it learned it from 2 routers. It learned it from router 2 and router 3. They're the ones advertising it. And then router 5, do show IP BGP. So what happened here, and this is where we're going to focus now on the next hop self. And this is why it's critical. So the way that BGP works is router 2 and router 3 have learned a route from an external BGP peer. Now, eBGP by default will use the interface, right? The next hop interface as the next hop address, right? This outgoing interface right here on that 1111 route that got advertised, that would be the next hop address for eBGP. But once it gets learned here, right? So router 2 learns it, and it learns it as an eBGP route. And again, by default, the next hop is that interface. But does router 3, 4, 5, and 7, do those routers know how to get to that interface? They don't, because they're not learning that interface as they're not learning this transit segment here. We're not advertising that transit segment into BGP, and for good reason, right? We don't want it to be advertised. So that's why on the iBGP peerings, right, router 2 learns it, and the next hop, which is a mandatory attribute, is going to be the outgoing interface of router 1, the interface out which that BGP update originated. That's the next hop. The problem is if router 2 were to send that route to router 4 and to router 7 and say, hey, the next hop is that interface IP, these routers in my autonomous system, they have no clue how to get to that interface, right? They're not learning a network for that interface. Remember, we're running BGP here. And you would not want to advertise that into OSPF because iBGP or BGP has a configuration setting that we're using right now to make it so that the next hop that I tell you for that route that I learned from an eBGP peer, the next hop is me, next hop self. And so the next hop is the loopback address that I'm using, right? And that's how we've got our iBGP peerings configured. So that's why you need, one, the full mesh of all of the iBGP peers, right? Because that is how I'm going to be preventing loops, is through the full mesh. And two, we need the next hop self in there because that outgoing interface that the next hop value is going to be set to for the eBGP learned information, we need to change that because all of these internal routers, they're not going to know how to get to that IP address. So we change it and we say, hey, send it to me. And as long as it gets to me, I'll take care of everything else because I do know how to get to that interface. I'm directly connected, right, with that eBGP peering. So that's why we have that configuration command, next hop self. That's why that is put in for all the IBGP peers, right? Or peerings. You don't do that with eBGP, because with eBGP, you don't do it because you wouldn't do that, because the next hop, you need to make sure that the next hop is going to be whatever value you get from where that route originated, right? That outgoing interface on router 1 in our case. All right, so that takes care of all of our IBGP peerings here. Now let's move down to router 6. Now we're going to have to do the eBGP on 4 and 5 to router 6. But for right now, let's come down. We'll knock router 6 out to kick things off here. And like I said, we'll get the eBGP peering set up. I'm going to advertise the 6666. And remember, I need to show you a network statement with no mask on it. So we did the 1111. I'll do the 6666 with the mask, but I need to show you that you can do it at a classful boundary. You don't even have to put the mask value, but it has to be a classful boundary. So let's get router 6 set up here for some eBGP action. So we'll get into global config. Router BGP 6, because my autonomous system number is 6, right? And I'm simply going to say neighbor 169.254.46.4 is my neighbor. And the remote autonomous system is 23457. Remember, these are eBGP peerings. This is super easy because right there, I'm done with the peering for router 4. To do router 5, I'm just going to pull this back up and change the last 2 octets. It'll be 56.5, and that's it. And now let's advertise the 6666. I have to put that, it's got to match exactly, right? The IP subnet mask has to match exactly with what we've got configured, right? Or I should say the network subnet mask needs to match exactly, right? So that is going to work. So let's come over to router 4. And we're already in the BGP config section. So I'm going to say neighbor 169.254.46.6, remote AS6, and we're going to see this remote autonomous system come up. There it is. Neighbor 169.254.56.6, remote AS, I'm sorry, I just realized I need to move over to router 5, and let me confirm that. And yeah, router 5 to make that happen. So neighbor 169.254.56.6, and then the remote AS is 6. And we should see the peering come up here. And we'll give it a second. And let's make sure the interface is up. And again, BGP is a little slow. Don't panic yet. And there we go. As you can see, as I was typing the ping command out, then BGP finally decided it was going to do its thing. And we've got the peering set up. So if I come over here to router 6 and I say show IP BGP summary, whoops, summary, we're going to see that I've got 2 peerings, right? And take a look at that. I've learned a prefix from both router 4 and 5. And the prefix is going to be that 1111. So if I say show IP BGP, there it is. Right? I've learned the 1111, and take a look at the next hop value. So this proves the point that I was making earlier, is for the eBGP peerings, the next hop value is going to be the outgoing interface out which that BGP update was sent. And you can see here, router 5 sent it out its interface, .5. Router 4 sent it out its interface, .4. Now take a look, we've got 2 autonomous system paths here, right? So here's my AS path, listing. I would have to go through AS23457, then AS1, right? And it's read from left to right here, but if you read it from right to left, it's where did it originate? It originated in autonomous system 1. So when we look at the AS path, in a lot of cases, you want to look at it from right to left. So where did it originate from? So that route 1111/32 originated, and you can see here, there's that I, right, with the network statement. And it originated with the network statement from Autonomous System 1, and then I learned it because there's no other autonomous systems listed here. I learned it from Autonomous System 23457. Now, I'm learning it from 2 routers. Right now, we're just going to go ahead and accept the fact that it says that that's the best path. In fact, if I was to, well, actually, let's go to router 1, and we're going to test end-to-end connectivity here, right? Let's see if this works. Show IP BGP, right? The BGP table, take a look here. It's learned the 6666. So it originated in Autonomous System 6 and went through 23457. And my best path is currently router 2. So when we look at this, if I was to say trace to the 6666, if I hit enter right now, do you think this is going to work? And I'm going to tell you that it's not going to work. And I'm going to kill it here in a second, but we'll let it go ahead and sputter for a while. So the reason it's not going to work is because ping and traceroute by default, if I just say ping 66, and the ping wouldn't work either. So if I say Control-Shift-6 to kill it, if I say ping 6666 and hit enter, it's not going to work, right? Because ping and traceroute by default, as the source address in the ICMP packets that they send, by default, the source address is the outgoing interface address. In this case, it's that 169.254. Well, guess what? Router 6 at the other end has no clue about these 169.254s. That's how we want it, right? That's what we want. So what I have to do is I have to say trace to the 6666, and I source it from my loopback address that router 6 does know about, right? The 1111. So if I source it from a route that router 6 knows about, and then all of the intermediate routers know about, we're going to have success. And there we go. So I go to router 2, router 7, router 4, router 6. So that's the path I take. Same thing with ping. If I say ping 6666 and I source it from the loopback address, again, a route that router 6 knows how to get to, the ping works. So we've got end-to-end connectivity right now. So now let me close out by talking about the network statement. Because again, the network statements cause a lot of issues when you have variable length subnet masks, right? When you've got CIDR notation and you're subnetting things. Excuse me. And actually, let's do this from router. We'll do it from router 1. So on router 1, if I go into global config and I go into router BGP 1, and actually we'll create the interfaces first. So I'm going to say interface loopback 192, or we'll say 172 first. So the IP address here is going to be 172.16 and we'll just say .1.1. But I'm going to make it 255.255.255.252. I'm making it a /30, right? It's a /30. But what's the default mask for that? The default mask for that is a /16. So I have to make that match exact, or actually let's do this. I'll change it. We'll make it a 16.0.0. So we'll make it a 16 because I want to show you that you don't have to put the mask argument in there if it matches exactly. Let's do an interface loopback 192. And again, I'm just creating some virtual loopback interfaces that we can use to advertise with the network statement. So IP address 192.168.1.1, and it's going to be a /24. And remember, again, for a 192 class C, the default subnet mask is a 24. For the 172.16, the default subnet mask is a /16. So when I go into router BGP 1 and I say network, all I have to say is 172.16.0.0 because the network, the interface we're trying, or the advertisement that we're trying to make is using the default classful subnet mask. So I don't have to say mask 255.255.0.0. In fact, if I did that, and let's use the 192 as an example, I'll make sure I got the right thing there. Yep. and I say mask 255.255.255.0, Cisco iOS on recent releases, on current releases of the software, is smart enough to know, hey, you don't need to put that in there. And in fact, it's going to go ahead, do show run section router BGP. It's going to go ahead and save you the embarrassment and just remove it for you because it's not even needed, right? Because it knows what it's going to do is by default, it's going to use that classful boundary to do this, right? So if we're using a classful network, we don't need to put the classful mask. It knows it. And again, remember, that's all that's needed for these advertisements to work. So now let's come all the way down here to router 7, all the way down here to router 6, right? And if I say show IP BGP summary, we should now see that we're not just learning one prefix, we're learning 3. And we're learning them from router 4 and 5. And what are they? Show IP BGP. There they are. We're learning about the 172.16.0.0 and the 192.168.1.0. So let's see, can I ping those addresses? So ping 172.16.1.1, source from my loopback address. Sure, it's going to work, right? How about a 192.168.1.1? Source it from a loopback address, right? Remember, I got to source it from an address that router 1 and all the interceding routers know how to get to. And my loopback, because I advertise that out into BGP, they know how to get to that address, right? And so when we take a step back and we look at the network, and it's actually probably better to look at it here. When we look at it here, right, we can see that we did the advertisements up here on router 1, and all of the other routers have learned about those routes all the way down here to router 6. And so router 2 is going to tell router 4 about the 172 and the 192, and 3 is going to tell 5, and that's how 4 and 5 know how to tell 6. And that's what BGP does, right? BGP is all about, you know, telling neighbors, hey, here's a route, and here's the autonomous system path with my autonomous system included, right? Because I'm telling you about it. And that's how, you know, this is how the internet works. And again, we've got a very small scale that we're looking at here, but on a larger scale, this is what's happening on the internet. And I'm actually fortunate enough to work in an organization where I'm actually working with service providers where we're setting peering connections up with AT&T and with Verizon, and we now have our own in-house service provider where we're doing all kinds of international connectivity with weather organizations over in Europe, in Germany, Darmstadt, Germany, in France, in UK Met, and England. So we're setting up all of these peerings, and we're using BGP to facilitate that, right? And so, again, it's very, very simple to set BGP up. It gets tricky when you start to look at some of the more advanced applications. But at a basic level, this is how you would set BGP up. Now, for week 2, for next week's Zoom session, we're going to get into the best path selection algorithm, and then we're going to start to manipulate the best path, right? We're going to talk a lot about control versus influence. And so there's a discussion topic that talks about that, I think, next week. And it talks about the difference between control and influence, right? So, and remember this is critical. With BGP, I can control what I am advertising. So they talk about it in terms of egress, right? The egress routing information that I am advertising, I have full control over the path out which that routing information leaves my autonomous system. Full control. Now, when we look at router 6 here, right? Router 6 controls how it's going to get out of the autonomous system, but it can't control the ingress flow of traffic. So in other words, when router 1 up here is making its way down to router 6, router 6 does not have full control. It can try to influence whether the traffic comes from 1 through 4 or 5. It can try to influence if it's going to come through 4, right? The traffic from router 1. Router 6 can influence or try to influence if it's going to come through 4 or if it's going to come through 5. But it can't control what's going to happen. Because remember, the definition of an autonomous system that you see used all the time is under a single administrative control, right? And remember, I said with BGP, you can only have full control over the egress flow of traffic, what is leaving your autonomous system. So here, right, autonomous system 23457, they control how the traffic from router 1 is going to get to router 6. They control whether it's going to leave out router 4 or router 5. They have full control over that. Now, 6 can try to influence it by using AS path prepending or using MED, right, the multi-exit discriminator. It can try to influence it, but ultimately, autonomous system 23457 will control how that traffic gets back to or the traffic comes from router 1 to router 6. And so we're going to talk about that, and you're going to see, and I'm going to show you examples, and we're going to set the policy up, and you're going to see how that works, and you're going to find out that, yeah, because of the best path selection algorithm, right, I can only influence how that traffic comes to me, right? I can't control it fully. I can just try to influence it. And so we'll see what that looks like next week. And so let me ask you guys, as I always like to ask, to make sure that I'm kind of on point here. I'm sorry, let me get out of this, get rid of that and get back to this. So let me ask you guys, I want to make sure that I'm on point. Did this help you at all in terms of understanding how BGP works, right? How we set up eBGP peerings, how easy that is, how we set up iBGP peerings, why we need to have the full mesh, why we need to have next hop self, and that is critical with iBGP peerings, setting up next hop self, and taking a look at the BGP, the main BGP table, right? There's other BGP tables. There's an adjacency rib in and adjacency rib out that we could look at as well. So does this make sense? Okay, so Roger, good. Kayla, is this helpful at all, what we covered tonight? Did this clarify anything? And again, this is kind of like our smooth landing here into BGP. Okay, good. Yeah, because next week, and this is going to be tricky, so if a learner doesn't watch this session and then sees the session next week, chances are, and again, if they're new to BGP, it's going to get extremely complicated very quickly, right? So, all right, good. Do you guys have any questions over anything that was covered? And I know that we're at 90 minutes right now. So any questions over anything that was covered? I'll give you guys a few seconds there to type something in. All right, so no questions, it looks like. Let me go ahead and kill the recording then.